Composite shapes are made up of more than one basic shape, so they are stuck together. You can add or subtract to find the area and perimeters. Just make sure you know which one you're looking for of composite shapes. So we know the rules of how to find this information. We just need to be kind of smart about it. The layout of the relevant mathematical working needs to make sense so that the reader of your work understands each step. Well, how about that for news? All right. So find the perimeter and the area of this simple composite shape, rounding to 2 decimal places where necessary. Okay, so first the perimeter. The perimeter is going to be equal to all of the sides added up together. So we just kind of make sure that we don't miss any. We don't care about this bit for perimeter, but we will need that for the area. So let's just make sure we're doing the right stuff. So we've got 8 plus 8, because this is the same as that. That's going to be an 8, plus 8. Could have said 8 times 3 if I were in the mood, but I'm doing that. Now be careful here. This one is 5, plus this one is the same length as 5. It's not 3, plus 5. So if we add them all up together, that shouldn't be too hard, 24 plus 10, the perimeter is equal to 34 meters. Is it square meters? No, because we're just going around the outside. Now the area is going to be adding together these two different shapes. So as we said before, these are the same, and I'm going to presume that's the same as well, and that makes a square, which is length squared, or side length squared. And to that we're going to add the area of that triangle on top, which is 1/2 of the base times height. So 8 squared, 8 times 8 is 64, plus 1/2 of the base is 8, times the height is 3. And I think we can agree that 8 times 3 is 24, half of which is 12. I hope that didn't go too fast. And then I add them together, 676. So the area is going to be the area of the square plus the area of the triangle, which is going to be meters, and in this case it's going to be square meters. The area of the following composite shape. Give me a break. So you have to look at it and see what kind of shapes we can see in it. It's got a little dashy line there that shows us that that height, that dashy line, is 1, which is going to be useful for us. So what are we going to do? I'm suggesting we put another dashy line there. That's also going to be 1. So we've got a rectangle, and we've got 2 little tiny triangles, which we could figure out. We could also figure it out this way. And then we've got a square on the top. Sorry, that's not true. That's a rectangle. So we've got length times width using these two. So that gives us this area, plus a trapezium. And a trapezium is 1/2 of the 2 parallel sides, which we know because this will be 1.5, because we see we have a little right angle there. That's our little clue to make sure that's true, times the height. So let's plug in some numbers. Lengths times width, that shouldn't be too hard, times 1. Plus, I'm going to do my little trick where I put the 2 on the bottom. 1.5 plus 2.5 times the height here. That height is 1. Oh, that also makes life easy. And divide that by 2. So 1.5 times 1 is 1.5 plus 1, 2, 3, 4, isn't it? 4 times 1 is 4 over 2. So that's 1.5 plus 2. 1/2 of 4 is 2. So that area should be equal to 3.5 centimeters squared. Find the area of this composite shape. Hint, use subtraction. Okay, because I think we could do it either way, but let's try it. So what we have is a rectangle. We have length and we have width. And if we're going to use subtraction, minus, we've got, what do we have there? 2 triangles. So minus 2 times 1/2 base times height. So length times width is 6 times 11. I'm going to jump ahead and put 66. Minus 2 times base times height. This base is same as that base, so it's half of 11. So that's 5.5 times 6 over 2. So 66 minus is 33. Our area is 33 centimeters squared, because we took off the two triangles. Now this one looks tricksy, but it's not. And for this, we are going to find out both the perimeter and the area of this composite shape. So, and we're going to round each decimal to 2 places if that is deemed necessary. So perimeter, that's going to be interesting. So what we're looking at is a square, essentially, because we can see that each of these, there's 2 of those that are equal on each side. And so they must be equal to 2 each, because 4 is across the whole lot of them. So 2 sets of 2. So the perimeter is going to be equal to 2 plus 2 plus 2 plus 2. So that's all those flat shapes. Now, how are we going to figure out what these are? Well, these are actually semicircles. So we have 1 semi, 2 semis, that makes 1 whole circle. 3 semis, 4 semis, or 4 halves makes 2 whole circles, plus 2 times, we know the diameter, isn't it? So it's area, not area of circle, it's pi times the diameter. 2 times pi times the diameter, which is 2. So 2, 4, 6, 8, plus 2 times pi times the diameter is 2. That gives us, my perimeter is 20.566, etc., etc., but I'm rounding to 2 decimal places because that is 5 or bigger. Therefore, my perimeter is that square millimeters. My area is actually a little bit easier because we know these are circles. We've made the vast assumption that these are circles. So the area of this is actually going to fill in that area if we were to flip it around. And the area of this is going to fill in that area. So once we take these out of the equation, we've just got a very simple side squared. So they cancel each other out. Each of those semicircles can fit inside the circle. So the area is taken care of. They cancel each other out. And I've got 4 squared. So the area is simply 4 times 4, 16 millimeters squared. And there it is.